Mark Ryland. I'm a Director of Solutions Architecture at Amazon Web Services. I work in the public sector team. Joining me today, doing probably the bulk of the presentation, is Ming Zhao, who's a Senior Product Manager on the EC2 team, specifically working on virtual private cloud and related technologies. So we're very excited to be here this afternoon to talk about an important new capability launching today for VPC, launching on region today and rolling out soon across the entire Amazon footprint in all regions, with a couple exceptions we'll tell you about later. So here's what to expect from the session today. Just a brief outline, why v6 matters, a review of AWS networking so that we have a good context. It's not always super clear to people what the relationship is between certain parts of the network and others. We'll kind of go over that. We're going to review some of the core concepts of VPC today, particularly how NATing works and the fact that your EC2 instances are not ever directly present with public addresses on the internet. The way v6 in some ways is going to both have a lot in common with the v4 model, but some changes as well. We'll be doing demos throughout, and we'll have hopefully some time for questions. And if we run out of time with the audience this small, we can all gather in the hallway and we can hang out for a while. So looking forward to that. So there's a kind of a cottage industry that people have around trying to get across the concept of just how expansive the v6 address space is. And so I'll make my weak effort in that little world. Just think about, when you talk about so this is an example of not the entire address space, but just one subnet. A large v4 subnet, a /8, is about 2 to the 24th power, and it will be every pixel in a very high resolution screen of 10 inches by 18 inches. A similarly high, super high resolution screen of just a subnet range of IP addresses, 62 to the 64th, would be 169 miles by 300 miles at 300 dots per inch. So again, it's just a way of visualizing just how expansive this address space is. So obviously we're running out of v4 space. The world's been kind of teetering on the brink of that for a while. We've done a great job of putting off that day with NATing and other techniques. But there's going to come a time when the piper needs to be paid, especially in the IoT world. We're getting to see that transition in the mobile world. And so v6 is becoming a pretty critical capability. And Amazon Web Services is now able to get out in front of that. I work in public sector, and I've got a bunch of customers that have been eager to have this for a long time. Governments have had mandates around v6 for a while. To some extent, it was a checkbox, and yet there is a reality behind it. But what I've seen in my career is, at first it was a checkbox, it was a mandate for governments, but what's happened now is that we're seeing the demand growing strongly in the commercial sector as well. So we have ISP customers, we have TV cable companies that we work with, all of whom are very eager to have v6 as a native capability in EC2 and beyond. But the thing I want to communicate about v6 is it's not just about those millions of addresses, it's about what happens when you go from a world of scarcity to a world of abundance. It really allows some really cool capabilities. There's only a few we can point to today, but I think what you'll find over time is there'll be lots of new things we can do as we transition to v6 because we're now dealing with abundance. Just a couple quick examples. Today in CloudFront, for the first time, you can have a fixed set of unchanging v6 addresses for your distribution. Think about that. You can have A records for CloudFront. You could never do that before because the nature of the system was very dynamic, and you had to account for the fact that the IP addresses could be changing underneath you as you provide this globally present distribution of a CDN. Even in the very first launch here in VPC, one of the primary things that have been valuable about elastic IP addresses over the years is, hey, I want to have this unchanging thing that I can count on that's part of my account, and I can move it around and keep it as like a piece of property almost. Very valuable, very useful. Now in the v6 world, as you'll learn, that's a common characteristic of all the v6 addresses in your VPC. They're yours essentially for the lifetime of that VPC, that account, those instances, et cetera. And you'll see more and more benefits like that over time, where because of abundance, we can essentially assign these values and they can do real work in the real world, and yet each customer essentially can have their own, and maybe potentially a whole bunch of them. Overview of AWS networking. Sometimes it's not always clear to customers, in my experience, kind of how this lays out, but we've tried to represent this, what a region looks like, essentially here on the left side, if my pointer will work. you can't, well, we can sort of see it. There you go. So this essentially is the regional edge. And what you'll see there is you have a whole set of services that have, so all these essentially green dots are the v4 endpoints of various services. You have S3, you've got DynamoDB. These are all publicly addressable. And one of the lessons of that, of course, is that the ability to deliver packet to an endpoint is not directly related to the security of that endpoint, because these are all highly secure systems which we know very well how to keep secure, but yet they're addressable publicly. Nevertheless, in the traditional world of virtual machine networks, it's very handy to have private address space, which is what VPC has traditionally provided you. In the private space, you can, however, access the outside world through internet gateway and providing public IPs onto your instances. In addition, there's a whole set of public addressing as well at the edge services. So there's a whole range of things at the CloudFront POPs, the Route 53, the WAF service, and CloudFront, also part of the Amazon's public IP space. And that IP space, as I hope you know, is available programmatically. There's a JSON file which is updated as regularly as need be, and you can even get a SQS notification when it changes, which tells you what the address space of these various ranges are in the various regions around the world. So this is what we're dealing with now. There's a couple nuances, though, that I want to point out that maybe aren't quite as obvious that people should be aware of, in part because we're not going to overnight make all these v6 capable. We'll talk about what's v6, what's v4, but there's an important distinction here that you need to think about, which is between control planes and data planes. So a control plane is an API endpoint where you call the API to do, let's say, cloud work for you, but it's not typically what your customers, your applications are calling as they do their normal work and their normal processing. Some services, the control plane and the data plane are one and the same. So for S3, what are called abstracted services, if you look at our security documentation, you have this distinction between abstracted services, container services, and infrastructure services, which sort of the three types of which more and more abstraction is presented to you, or in the case of an infrastructure service, you have a lot of control over how they operate. So EC2 is the classic infrastructure service. Others are these abstracted services, just a black box. It's an endpoint in the network. You call it with the right signature and the right methods, and it works, and it does magic for you. So for those type of services, the control functions like create bucket and the data functions like get put object are one and the same endpoint. But that's not true for other services. So for example, CloudFront, you control your CloudFront distribution by calling the CloudFront API, but your customers using that CDN are hitting these edge locations, and so that's the data plane of CloudFront. And EC2 similarly has an API for configuring VPCs, setting security groups, et cetera, but the data flowing to and from your instances goes across this data plane. This is relevant because now if we talk about how we're beginning to roll out v6, we're focusing on the data plane, which is where the applications hit these services. Gradually we'll get eventually we'll get all of it, but the initial rollout today is this set of blue boxes, or blue dots now. So we have v6 available on all the edge services as of the last couple months. S3 actually was the first service to launch with a new DNS name you can use for a dual-hosted endpoint for S3. And as of today, we've announced the capability in EC2. Now we're going to go into a lot of great detail around this set of capabilities, as well as the Direct Connect feature. So that's where we stand. That's kind of the overview. Now I'm going to turn it over to Ming to take us into some of the details around VPC and EC2. And I'll be hanging around, and we'll have time, hopefully, to talk to you with questions at the end. Thanks very much.
Thank you, Mark. My name is Ming. I'm a senior product manager in the VPC team. And we also have the other product manager for IPv6 here, is Shan over there. And we are very excited to present this feature today. So before I get into details, I want to know a little more about who I am talking to. So can you please raise your hand if you are a networking professional? Thank you. So I see about half of you are professional networking guys. So as you can see, this is a 307 section. So it does require some general knowledge about IPv6 and VPC. So can you please raise your hand if you have general knowledge about VPC? Great, everybody. Great.
Beautiful.
Can you please raise your hand if you have general knowledge about IPv6? Awesome. Okay, great. So everybody knows general knowledge about IPv6 and VPC. So we are going to keep it a pretty fast pace, and I will try to talk as more as possible on the details and give you all the valuable information. So here, at the starting point, let's talk about a few key concepts about IPv6 in VPC, and let's start from the basics. So the first concept is dual stack. So as you can see here, this diagram shows a very simple, typical structure of a VPC. So you have this, you have your virtual private cloud here. It's a VPC. It has its IP ranges, and typically you can have one or more subnets in it. Here I'm only drawing one. And that subnet has a subset of the IP ranges, and then you launch instances in this VPC, in this subnet, or other resources here. And when we say dual stack, that means the VPC, the subnet, and the instances will be able to have both IPv4 and IPv6 addresses. So when it communicates the internet with the internet or other resources, it can use either one. So here are some example VPCs and subnet information here. They are the console screenshots. So IPv4 is the default. This makes sure the environment is backwards compatible. So if after this session you go back to configure our VPC, doing everything exactly the same way as before, nothing would change. It will be IPv4 only, so that if you have some workload configured there, it will not be impacted. And IPv6 will be opt-in. So when you need IPv6, you can request to have an IPv6 seeder block on the VPC. So here you can see this IPv6 demo. It is a dual stack VPC. It has both. And this default VPC is IPv4 only, the same behavior as before. And same here for the subnets. In a IPv6 enabled VPC, you can require a subnet to have IPv6 seeder blocks too to make it dual stack, or you can keep it IPv4 only. So if a VPC is dual stack, the subnet doesn't have to be dual stack. It can be v4 only or dual stack. The VPC seeder block, it comes from Amazon's IP address range. So it's always a /56. So when you request the seeder block, we just assign one for you. And the subnet seeder block is from the VPC's block, and it's always a /64, and you can pick one from those available from that VPC. So there are in total 256 you can pick from. And here are some example instances. As you can see, these are the IPv4 public and private addresses, which you are pretty familiar with, and these are the new IPv6 addresses. So this instance is single stack IPv4 only as before, and these two have been enabled to have IPv6 address. And by the way, it's not just one, you can have multiple here. So here, for example, I'm just putting one here. Now let me do a little bit demo to show the experience of using IPv6 on an instance. So I'll switch the screen. This is my EC2 console. I have 3 instances running here. They are all dual stack enabled. So I'm going to log into this demo A. It's a Linux instance, Amazon Linux instance. So it's right here. First, let's look at the IP addresses, if config. So I'll filter the output a little bit to only show the IP information. So you can see here, this is the private IPv4 address. And here, this is the IPv6 address. So if you compare this one with this here down on the console, they are the same address, right? And let's try using this address. So let's do a curl, and let's request to use IPv6. So I'm going to access this website. So many of you may know this. It is what is myv6.com. So this website can tell you what IP address you are using to connect to them. So what's your source IP? Well, it's a little bit messy, so let me do some filtering to only show the address. Oops. So the address is here. Oh, I have a typo here. Okay. So the website tells me I was connecting from this IPv6 address. And again, as you can see, it's the same as here. This is exactly the address I have. And as a comparison, if I request to use v4, and by the way, this website is dual stack. So it has both v4 and v6 address, so I can choose. So if I choose v4, you can see it shows the instance's public IP v4 address. It's the same as shown here. And one interesting thing is if we try, we don't specify a protocol. We just call that website. So what address is it going to show us?
v6.
IPv6 or IPv4? 4? Well, it's the 6.
Is the default.
Yeah, so here it comes to, this is one thing I want you to pay attention if you haven't noticed before. So when you call a dual stack service, and if you don't specify, OS and some applications has an order of preference, and there are some global standards about reference. But in general, when you are accessing the internet, in general, IPv6 is preferred to IPv4. So whenever IPv6 is available on both sides, it will pick IPv6. This is one important factor which we will come back to later when we talk about turning on IPv6 on an existing VPC. So now I will continue on this concept. And the other thing I want to call out here is, which is going to the next key concept, is here you can see, when I did if config, the OS showed me the IP it knows. It's that private IP address, right? So the OS knows nothing about the public IPv4 address. But when I access the internet, actually my source IP is this public address. So this is the magic of one-on-one NET. So many of you may know that. So it is in the IPv4 world, by default, every server, every instance would have a private IP address, which is not internet routable. You can use it to communicate within your local network, right? Do whatever you need. But whenever you need to go into the internet, you will need a public IP address. And on EC2, this public IP address is one-on-one netted to the private IP. So the OS only knows the private IP. Whenever it talks to the internet, it thinks it's using that private IP to talk to the internet. But the magic happens at the EC2 border. As soon as the packet leaves EC2, EC2 would replace that private IP with the public IP, so then the packet go out. So the internet always see that public IP. It never know about the private IP, right? So that's a very important concept in IPv4. And this will lead to some difference between IPv6 and IPv4. Now let me switch back to the presentation slides. So the next concept about IPv6 will be global unicast address. So before going to that, let's quickly review some key concepts of IPv4. Yeah, so as I talked just now, so IPv4 by default gives you the private IP. And when you need to talk to the internet, you will need a public IP. And there are, in general, two ways to get it. One way is you get a public IP for this server specifically. That's what I talked just now. So on EC2, we do one-on-one NAT. The other way is you have multiple servers sharing the same IP address, and there's one very popular technology which is called network address translation, or NET. It's also NET. However, it's actually PAT. It's actually port address translation, but we typically call it NET, right? So the way it works is whenever these servers send something to the internet, the packets are first forwarded to this NET box, right? You typically put a box there, a middle box there. That box would replace the source IP with that box single, not necessarily single, but with that box's public IP address, then send it out. So the internet still don't know who it's really coming from, because no matter how many servers are there, it's all sent out from this single NET server. And there may be multiple servers accessing the same service. So when the response comes back, the NET server needs to know which backend server is actually requesting this specific one. So the way it does is whenever it sends something out, it assigns a port, and it makes sure the request, every request has a different port number. So when the response comes back according to the port, it will translate the address back to the private address of the specific server. So this is how NET works in general. So in IPv4, a lot of people, I guess many of you spent a lot of time managing the NET boxes, right? So on EC2, we have NET instances, or if last year we launched NET gateway, which makes it much simpler. On IPv6, there's a very big difference. Although IPv6 was not trying to do a revolution, it inherited a lot of things from IPv4, but this is one thing IPv6 tries to do very differently, which is IPv6 now has this immense IP space, as Mark has just introduced. So we don't have to worry about the IPv6 space anymore, at least before the end of my training. So now we say, okay, let's give every server a public address. And as you can see, the IPv6 default is global unicast address. So it's globally unique, right? It's internet routable. So now it comes to, okay, so we don't have to do one-on-one NAT anymore. We have enough address to give every instance one public address. So on IPv6, when I was demoing, you can see that the OS knows exactly that address, and it goes out directly. There's no one-on-one NAT, no changing, and the internet sees exactly the same IP. This is one difference. Another difference is, oh, by the way, so when I say this, so some of you may think, okay, that means it's a public IP because it's internet routable, and may start to worry about security, thinking about, well, if it's internet accessible, does it mean I lose some security? I expose this box to the internet? The answer is no, right? So having a public address doesn't mean you can access the internet, especially in a VPC, which is designed by default for security, for keeping your resources private, right? So in order to have internet access from a VPC, beyond having the right IP address, you also need to configure the route table, configure the security groups, which is the firewall, sometimes network ACL, and sometimes you also need to have the right gateway, for example, internet gateway, or some other kind of gateway which can directly or indirectly send your packets to the internet. So having this globally unicast address doesn't mean you are losing security. Actually, it's still pretty good, right? You can do all the kind of protection you need in a VPC. And because of this IP space, we found that we actually no longer have to do this NAT thing, worry about this middle box, right? Because you don't have to share IP address anymore. And a lot of time, people use NAT to share address. So now you can just use every instance's own IP to access the internet. But when you talk about security, when you use NAT, actually what you worry about is you don't want internet to be able to reach in. You want to reach out, but you don't want the internet to reach in. So actually the one thing you want for security is the egress-only access, right? Blocking ingress traffic, allowing egress traffic. So here, we are launching this new feature, which is called egress-only internet gateway for IPv6. So using this, it's going to block, it's like an internet gateway with a stateful firewall. It will permit your instances to send traffic out. It will allow the response to come back into your instance. But if the internet tries to initiate any connection, it's going to fail. It's going to be blocked. So in this way, it will keep your private, it will keep your subnet protected. And in your private subnets, if you want to create this kind of egress-only internet access, you can use egress-only internet gateway. And as you can see here, there's no middle box. So there's nothing to worry about performance or availability. It's a virtual device. The actual devices are highly distributed across the whole EC2/AWS network. So it's highly available, no throughput limit, and there's no charge, no additional cost. Right. Now let me do a little bit of demo. About the egress-only internet gateway. I'm switching back to this box here. So here's what I'm going to do. So I have 3 instances here. I just logged into this A. So it's in it has public internet access. This demo C instance, it is placed in a subnet. Oh, oops. Okay, this C is in a subnet that is using an egress-only internet gateway. So this instance can initiate communication with the internet, can initiate outbound traffic, but the internet cannot reach into it. And this instance is in a different VPC. So this instance can communicate with the other two over the internet, but not through other private channel. So what I'm going to do is I'm going to log into this instance C and to reach out to this VPC2, this instance. And also at the same time, I'm going to log into this instance to try to ping this C, and let's see what's going to happen. So first, let's log into C. Oops. Because I cannot reach in from the internet, so I'm going to log into it from this instance A, which is in the same VPC at C. So I'll just use this IPv6 address to SSH. Yep, I'm on that. So you can see the private address here, 10.100.222. It is here. So I'm on this C instance. Okay, now I'm going to find out the address of this instance in the other VPC. And I'm going to ping it from here. So when you ping, you do ping 6. You can see this is egress traffic. It works, right? The packets can go out, the return response can come back. And now let me log into instance C. So I just use A as bastion. So let me log into this instance. It is publicly available. It is internet accessible. So I'll just SSH from here. Okay, I'm on it now. You can see here, 0176, 0176. And I will ping back from the internet. As you can see, it stacks here, right? When a ping stacks, it means the packet isn't going through. The packet is lost. And if we put them together, you can see this one is egress traffic, it's working. This one is ingress, it's not working. And I'm going to do a little bit tweak here. I'll go to the VPC console. I will switch it between egress-only internet gateway and the internet gateway. And let's see what's the difference of the behavior. So that instance C is in this demo VPC. I'm going to find out its route table. So this is the route table that is using the egress-only internet gateway. And from the rules here, you can see it is sending everything to the egress-only internet gateway. So what I'm going to do is I'm going to edit it. I will delete this IGW and use this internet gateway. So internet gateway ID starts from IGW. So let's do a quick check. So this inbound not working, outbound working. So let's come back, commit the change. And let's see, outbound still working, inbound starts work. So this is the real internet gateway. It's two-way internet access. And now let me switch back to the egress-only internet gateway. And the inbound traffic stopped. Yeah, so this is the new feature. Yeah, it gives you the benefit of NET in terms of security, protecting your instances from the internet at no cost, at a much simpler way to use. Okay, now let me get back to the slides. Let's see some general concepts of IPv6 in VPC. So we talked about dual stack. We talked about this big difference about public IP being globally internet routable and we talk about egress-only internet gateway. So as I said, IPv6 is not trying to do a revolution. So most of the things will work the same way as IPv4, right? So here in the VPC is the same. So most of the concepts in VPC will work the same as before. For example, internet gateway, you don't have to do anything. It will work for both v4 and v6 by default. So once you put the route there, either it's v4 or the v6, the traffic will just go through. You don't have to worry like, do I need to turn on something on internet gateway? So there are a few things that are important for security. Security groups and route tables, so everyone needs to use them. Some people use network ACLs for additional layer of control. So in these things, as you can see on this example here, example security groups here, you can use both v4 and v6 rules in the same security group, or in the same ACL, or in the same route table. And the v4 rules will apply to v4 traffic. v6 rules will apply to v6 traffic. Security group has one unique thing, which is referring to another security group. So any instance that associated with this security group will be able to communicate to this instance. And this reference applies to both IPv4 and IPv6 traffic. In general, because these three objects, security groups, route tables, and ACLs, are related to security, right? So it's very sensitive. So in general, AWS doesn't touch these things. We don't edit them. So it is totally yours. So you control them. You are responsible for it. However, there are a few situations where it is a little bit different in terms of when you are turning on IPv6. So some of you may have noticed that security groups have inbound rules and outbound rules, right? So outbound rule, and all the security groups by default have open to all rule for outbound. So you can reach anything unless you change it, right? And this is some very fundamental setup in VPC. So every security group comes in this way, and very few people change it. So when you turn on IPv6, if we don't change this security group, we don't add that v6 rule there, a lot of people would just forget it. And then they have an address there, they run it, it doesn't work. It's going to break some workload, it's going to break the experience. So we are not going to change your security groups, route tables, or ACLs unless we have the following three situations. The first, in your security groups, if you did not delete or modify that egress open to all rule, we are going to add a egress open to all IPv6 rule when you turn on IPv6 in a VPC, which is when you request an IPv6 CEDAR block for your VPC. In your network ACLs, for both inbound and outbound, they are default open. They default have open to all rules. So if you did not change these IPv4 open to all rules, we are going to automatically add open to all IPv6 rules. And in route tables, there is always a local route. It's not editable. So as soon as you turn on IPv6, you will see the default IPv6 rule to the local CEDAR. So these are the only three situations we would add something to your route table, security groups, and ACLs. And of course, if you change these open to all rules, if you are running some highly sensitive workload, you have specific rules there instead of open to all, then we will not touch it at all. We will not add that open to all. So it's totally up to you to add these rules. So if you are using these custom rules, and if you are turning it on and you have the internet access, make sure you put the correct rule there. Now, we come to how to turn on and off IPv6 in Amazon VPC. So you can turn it on as soon as you create a new VPC, or you can turn it on for an existing VPC, which may be very applicable to many of your work because you may already running resources on EC2 and you want to start using IPv6 with them, right? So if you create a new VPC, there will be an option. You can put IPv6 CEDAR blocks there immediately. So it will start, you can start as a dual stack VPC. If you have an existing VPC, this is the order and the tasks to turn them on. So because you have the general knowledge about VPC and a lot of you are professional network admins, I believe this is pretty intuitive to you guys. So starting from the VPC, give it a CEDAR block, then give subnets a CEDAR block, then configure security groups and route tables in the ACLs and gateways if applicable, if you are using some of them. then assign IPv6 addresses to instances. I want to call the order here 3 and 4. Yeah, so please make sure you do 3 before assigning addresses to specific instances. This is the reason why I called out the dual stack behavior just now. Because if you don't do this, you may not have the right rules or routes or gateways to permit the traffic to go out to the internet. However, as soon as instances get IPv6 address, this thing is usable, right? So if your workload is calling some dual stack URLs, your application will try to reach out to the internet using IPv6, but because you don't have the right firewall rules or route tables to permit the traffic to go out, this traffic will break. And then it's all at the mercy of the application. Some applications like curl, which I used just now, does a very good job to retry. So if it tries using IPv6, it doesn't work, it will retry using IPv4 and then find a way out. But some applications doesn't. So it's not a universal standard. It's about the coding habit, right? So in case you get a letter, the traffic will break even though IPv4 is actually available there. So that's why we emphasize here, make sure you get all the routes, all the firewall settings right before assigning IPv6 addresses to instances. And when you do this, if you are using the latest Amazon Linux Army, or if you are using the Windows Army, like most of the Windows armies, they have IPv6 turned on. So as soon as you assign, so after you assign IPv6 addresses to these instances, so this OS has DHCP v6 client running all the time. So it queries the DHCP v6 server every few minutes, 1 or 2 minutes, to say, hey, do I have some new information about v6? So as soon as we assign this in the next cycle, we will add, the system will bend the traffic to the DHCP client, and the client will install that IP for your OS. So that's what we saw just now through ifconfig. If you are not using this latest version, or if you are using some other OS and they may not have it turned on. So you may need to find out the menu, or you can refer to our documentation. We have some instructions about how to turn it on. So basically, you will need to change a few lines of your config files. It's not hard. So basically, most common OS has the ability to handle IPv6. You just need to turn it on. And this step is not strictly here, so you can do it earlier, or you can do it once, then save the army and use it all the time. So you don't have to do it every time. And then, whenever you need to roll back, or like you try something, you are not happy with it, you want to go back, so the way to turn it off is pretty simple. You just reverse this process. Like you can close the connection from the firewalls and route tables. You can unassign the addresses, then you can even totally remove the CEDAR blocks from the subnets and the VPC. Just convert it back to IPv4 only environment. So this actually gives you a very smooth transition and experience and great control, right? So you can turn it on step by step. You can turn it on one instance first, try it, make sure it's running well, then do it with a few more instances, then maybe deploy it to the whole fleet or to the whole application. And whenever you don't like it, you can roll back part of it or all of it. It's totally under your control. Now let me do a little more demo here. So let me show you, for example, when you create a VPC, these are pretty much the same as before. The new thing is here. Now you can have this option to request the Amazon provided IPv6 CEDAR block. And the same if you create a subnet. And this is a v4 only VPC, so you would see the same thing as before. But if you choose a v6 enabled VPC, you will have the option to assign an IPv6 CEDAR. If I choose assign, it will let you pick 1/64 from your VPC's range, right? So these are the /56 prefix. You don't change it. You change these 2 digits or 8 bits. To make it simple, I'm going to use the wizard on the dashboard. So there's a wizard. There are 4 very common scenarios of VPC. I'm just going to use one of them, so it will create everything for me. I don't have to do it one by one. So this is going to create a VPC with one single subnet, which has internet access. I don't need to change it here. So here, this is the new option I will take. I want IPv6. Let me give it a name. Today is December the 1st. So let me just do 12.1, demo 12.1. And this is my subnet information. I want this subnet to have an IPv6 address, IPv6 header block. I'll just use the default 00. And I will leave everything else as default, then create a VPC. That should be pretty quick. Yeah, it's here. So if I come here to see this VPC, you can, let me show all the VPCs. Yeah, this is my VPC. I just created, and you can see this /56 Amazon-owned header block is assigned here. By the way, it's Amazon-owned, but just like EIP, it's assigned to you, so it's totally under your control. We will not force you to give us back, so you feel free to use it. You kind of own it, right? So it's yours. And if you look at the subnet, let me do the demo. Yeah, filter a little bit filtering here. We see the subnet. It has this /64 header here. This is what we chose, 00. And I want to show you one thing here, which is auto-assign IP settings. This is an old option. So you can say any instance launched in this subnet should have a public IPv4 address. This is to make it simpler for the v4 experience. Same here, this is a new option. So if you tick this one, whenever you launch a new instance or a new interface in this subnet, it will be automatically assigned one IPv6 address. So that means if you want to make IPv6 the default option for your network, if you want every new resource in your network to have IPv6, you can tick this one. And for the simplicity, I'm just going to take both, save. And before going through the other VPC objects, I'll go ahead to launch an instance in this subnet. So I'll just use the very common launch instance wizard. I'll just use this first army and use the default instance. Here, I will choose the VPC we just created, demo 1-to-1. And the others can follow the default setting. Give it a name so that we can easily find it out. And please remember, many people forget to configure security groups. Then they find they cannot connect to it. Right, so remember to change the security groups here. So I'll just change it for the purpose of demo. I will make it open to all, but I'm sure you know that this is not the best practice. In your real production workload, make sure you do some specific configuration, and I will do anywhere. And you can see it has auto-filled both IPv4 and IPv6 here. Yes, I have this key pair. I'll launch it. Okay, while the instance is launching, let me go through a few other objects here. So this is the route tables, which I used just now. As I said, you can see this local route was created automatically by the system. And this internet route needs to be manually, or you use a script, CloudFormation, whatever preferred tool to create. If we look at network ACLs, you can see the inbound. So I didn't change anything about ACL. So it had the default OpenToWall v4 rules, and the v6 rules were added as soon as I created the VPC. And outbound, the same here. For security groups, there's no change here. It's the same as in a v4 only VPC for inbound rules. For outbound, the system automatically added this OpenToWall rule for v6 because I have this OpenToWall for v4. Okay, now let's go back. Oh, okay. Egress only internet gateway is here. Yeah, this one is very straightforward. You just create a egress only internet gateway, choose a VPC, and create it. There's nothing to configure. It's very simple, straightforward. Just create, use. Okay, now let's have a look at the instance. This is the one I just launched. As you can see, v6 address is already auto-assigned. Now let me try to log into it. Not sure if this is still working. Okay, cool. Yep, now this new instance is working. And it has the IPv6 address. Okay, now I will continue with the slides. Here's a list of other available VPC features that supports IPv6. I talked about security groups, route tables, network ACLs, talk about egress-only internet gateway, talk about VPC CIDR, subnet CIDR, and instance addresses. Internet gateway supported by default. VPC peering and VPC flow logs would support IPv6, just same way as for IPv4. Direct Connect, you will be able to add a IPv6 BGP session to either your existing virtual interface or a new virtual interface and attach it to the VGW. Instance metadata and Amazon default DNS servers will support IPv6 payload. So that means when you query the metadata, you will see the IPv6 information for your VPC. When you query the DNS for Quad A records, the V6 records, you will get the response. They still work over IPv4. So the transit is over IPv4. You still connect to the .2 v4 address for DNS, for example, but payload is V6 enabled. As you can see, this is a pretty convenient set of features we have launched. It's definitely more than a minimal viable product. So when we did this, we want to make sure most of you guys can use it conveniently if you want to turn on IPv6. And many guys may ask about a few other features. For example, why elastic IP address isn't in the first launch, because EIP is very popular in IPv4. The reason is that we talked to customers, we found that when people use EIP in IPv4, most of the time, the purpose is to get a persistent public address, right? Because if you don't use EIP, you use the default public IP, you lose the address as soon as you terminate the instance. But you need to preserve it, and whenever you change the workload, you need to continuously have that IP. Most of the time, you don't really need to move it across subnets or across AZs or across VPCs. So, and in IPv6, you can see every address is public, right? Every address from the VPC is public, and they belong to you, and they are always there, they are persistent. So the need for EIP has been much lower on IPv6. This is why EIP wasn't in the first launch. And more will come. We will continue working on that. At some point of time, the whole world will be running IPv6, right? So we will continue working on this. Here are the instance types that support IPv6. It's a long list. To make it simple, if you look up all the current generation EC2 instances, all of them, except for M3 and G2, support IPv6. Yeah. So if you are using some M3, you can consider moving the workload to M4. Right, so it's pretty rich. In terms of purchase options, it supports all the three popular options, on-demand, RI, and Spot. Spot Fleet will come a little bit later, but it will come soon. Regions, it is now available in the Ohio region. We turned it on this morning, and we are running a lot of press releases these days. So the press release for this one will come sometime later today. All other commercial regions, except the China regions and the US Gulf Cloud region, will come very soon. Some recommended sessions. Since you all have knowledge about VPC and IPv6, you may not need to take the basic sections. But we have a 4 p.m. session today to talk about the general IPv6 in the whole AWS. So its focus is on other services and on IPv6 general. You may find some of the information valuable to you. And tomorrow morning, we will have this next generation networking to talk about the new capabilities in VPC, both of which may be related to our work. So since we have some more time, I want to quickly show you the experience with flow logs. It's very quick. Actually, it's pretty simple. Okay, so I will start here. Oh. For some reason, it logged out. So I will start here. So this is the demo VPC I have been using. I turned on flow logs before the training. So if I look at the logs from it, so let me see which interface I was using for the main instance. I was using this instance. Its interface is 64D. So if we look at the logs of this 64D, in the past, let's see, do we have something in 5 minutes? No, what about 1 hour? Yeah. So let me scroll down a little bit. Okay, you can see it here, this line. It is an IPv6 record. So everything is the same as IPv4, except the addresses look a little bit longer. Okay. So now we will go into the Q&A section. And before starting that, I want to remind you, make sure you do the feedback, do the evaluation forms, so that we can hear from you. We can keep doing it better and better. Okay, thank you guys. So if you have questions,
Come to the mic, please.
Can you use that mic?
If you don't mind, that'd be great.
I just have 3 quick questions. So in terms of opening the /56, the VPC, is it possible then another customer could seize that same 56 later? Or?
Yeah, so if you delete that VPC, the setup block will go away. What we do is we reserve it for a certain length of time before allocating it to others.
So it would be possible to recreate a VPC 2 hours later and reclaim that 56? Probably not at
Definitely not 2 hours, but sometime later, maybe 1 year later, sometime later.
A short time later.
Yeah, they may get that.
Okay,
yes.
great. Next question is, if you have instances in an auto-scaling group that register to a load balancer, will the
sorry, excuse me.
If you have instances in an auto-scaling group that register to an elastic load balancer, will the elastic load balancer prefer IPv6 for the proxy traffic between the load balancer and the instances?
Yes. So the question is, will load balancers support IPv6?
On the back
Which
end.
would prefer?
On the back end.
Yeah.
So will load balancers support IPv6 on the back end?
What's that?
So is the question that will load balancers support IPv6 on the back end?
Correct.
Between load balancers and the back end instances?
Yes.
Yeah. I don't think it's coming very soon. It is something on the feature list, I think. And the best way to get the answer is to talk to the load balancer team.
Okay, thanks. And sorry, last question.
If you enable both, then it will. Once the feature's fully
then it'll
shipped, then
at some
it'll
point switch
prefer
over.
just like normal.
Gotcha.
Prefer V6.
And last question is obviously because many important hosts on the internet don't have IPv6.
Yeah.
If you're using an egress only IGW, is the current best practice simply that you also do have to deploy NAT because if you need to reach an IPv4?
I want to call that we do have IPv6 load balancer GA coming very soon. And it will support IPv6 on the front end, so the internet can access the load balancer using IPv6. But between the load balancer and the back end, it's going to continue using IPv4 because it's just we don't see the need of like using V6 for the back end.
Yeah, understood. Yeah.
Yeah.
No, but and just my last question though was: is you currently the best practice recommendation for NAT is still that even in using an EIGW, you would still need to deploy NAT because obviously probably many hosts you would need to reach on the public internet would not be IPv6 accessible. Is that correct?
In terms of NAT,
Yeah.
So we talked to customers before this release, so we didn't hear a strong demand about NAT. What we are going to do is we will continue.
He's asking
That's not what I
something
said.
slightly different. If you're
What's that?
Right. So to answer
yeah.
so to answer your question, yes, if you're trying to be careful, you're going to want to have both paths out to the internet, which means you're still going to have a NAT, some NAT path out to the internet.
Oh, okay, I see. Yeah, so
Use for v4, you'll need both to be safe. But if you have a specific use case where you know your endpoints are available, then it wouldn't be necessary. So,
yeah.
next question.
For the ELB public addresses, will those be in our VPCs in our /56, or is that going to be in Amazon's range?
Yeah, so the question is for ELB, if you use IPv6 ELB, will the IP be from your /56 range or from other ranges? It's going to be from your /56 range.
Yep.
Just looking for some clarification. It said that Direct Connect is supported, but there was a note on the bottom that said that VGWs weren't. So how does it connect the Direct Connect to the VPC?
So I'll take that one. So the VPN, the built-in VPN feature, which also uses VGW, is not launching today. The VPN use of VGW. The DX use works. The built-in VPN IPsec tunnel support is not there as of launch today.
So there is VGW with DX.
Yeah.
Works.
That works then.
Yes.
Yeah,
Okay.
yeah. Short answer is VGW works with IPv6. And VGW is a virtual device. It's all about what it is attached to. It's a VPN or DX or both. So the direct connect part will work for IPv6. Yeah.
Hi. So I'm hearing a lot of dual stacking, which is cool, but is there a v6 only option, or does it have to be dual stacked at this point?
At this point, it has to be dual stack.
Okay. So now that this is also supported in VPCs, is the option for DHCPing available both in EC2 space as well as VPCs?
The option of,
No, it will not be available in traditional EC2 networking, only in VPC.
oh,
Okay, cool, thanks.
okay.
Along the lines for backward compatibility and working with vendor or third-party networks, is there any possibility that customer-provided IPv4 siders are coming?
You mean customer-provided IPv6?
IPv4.
IPv4.
That's been a customer wish list for a while.
Yeah.
So we generally eventually get
One
to
of the
things
few
on customer wish
things
lists.
still locks us to a physical data center, and one of our few things where we
Yeah, we understand the requirement, and it's definitely something we're
Yeah.
taking a look at.
I suppose the other possibility is calling all of that legacy infrastructure and using it to force our vendors and customers onto IP6.
Right. And eventually people will probably want to bring their own V6 blocks as well.
Yeah.
So, yeah.
Yes.
Yeah,
But for now, we've got plenty. We have nice big allocations for our regions. So.
I want to bring my IPv4 to AWS.
Yep. Any other questions? Thanks very much for coming. Appreciate it.
Okay, great.
Yeah.
Thank you. Thank you, everybody.